elasticity. Elasticity is the property of a body by which it is able to resist deformation. Now, let me explain what is deformation. Now, when you pull a rubber band or you pull a string or a spring, there is a change in its shape and volume. Now, the force which you are applying is known as the deforming force, right? Because you are actually applying that force to change the shape and size of that object, right? And the body in reaction tries to resist that deformation. It will not try to deform, right? And once if you withdraw the deforming force, that body will regain its original configuration. For example, if you stretch a rubber band, right, will the actual shape and size of the rubber band be same after you have withdrawn the deforming force? No, because the rubber band is not very elastic. But if you apply the same force to steel, then what happens? First, it will not get deformed. Second, even if you apply a very large force to deform it, then after you have withdrawn the force, steel will regain its original configuration. So steel is more elastic than a rubber band, right? It may look like that rubber band is more elastic because you can stretch it very easily. No, that is not the elasticity. Elasticity is the property by which the body resists that deformation, right? When deforming force is applied to it and tries to regain or regain its original configuration when the deforming force is withdrawn. So a body or a material which can return to its original configuration very easily by after the withdrawal of the deforming force, that material is more elastic. Perfectly rigid body. A body is said to be perfectly rigid when no relative displacement, when no relative displacement between its parts under the action of a deforming force. So, a perfectly rigid body, for example, take your pen. Uh, when you apply a force to that pen, suppose you try to stretch the pen, right? The pen does not deform, means there is no change in its shape or volume, which means that there is no relative displacement between its parts. Suppose the head, the nail remains where it was, the tail remains where it was, the center position remained where it was. Means there was no relative displacement within its part under the action of a deforming force. Right. For example, let me draw. Suppose this is a pen, right, and you are giving a force. You are giving force. You are trying to stretch the pen in this direction. Now, even if you are trying to stretch the pen, this pen is not increasing in its shape or size, is not changing its shape or size, which means there is no relative displacement between the 2 points. For example, if I take a point here, if I take a point here and I take another point here, so after applying force, even when we are applying force, the distance between these 2 points, it is not changing. The distance between these 2 points, it is not changing, right? So this body is a perfectly rigid body. This body is a perfectly rigid body. Perfectly elastic body is a body which can recover its original configuration after the removal of the deforming force. When it can recover its original configuration after the of the force. Let me explain this to you. Take another body. Suppose this is the body. Suppose this is the body, right? And you have given a force to, you have applied a force to, you are stretching this body. Now, what happens? Due to the application of this force, this body has become like this. This body has become like this due to the application of this force. Now, what happens? You are withdrawing these forces. You are withdrawing these forces. When you withdraw this force, what happens? This body regains its original configuration. Regains its original configuration. So this is a perfectly elastic body. This is a perfectly elastic body. However, in practical life, we do not have a perfectly elastic body. Perfectly inelastic body or plastic body. A body is said to be perfectly inelastic or plastic when it maintains its changed configuration. When it maintains its changed configuration even after the withdrawal of the deforming force. Even after the withdrawal of the deforming force. Now what happens? Suppose, let me again help you with this by drawing it. Suppose this is a body, right? And you are applying forces just to stretch it. And after the application of this force, this body has become like this. This body after the application of force. Now you are removing these forces. Even after the removal of this force, even after the removal of this force, this body maintained its changed configuration. Originally, it was bigger and shorter in length and more in width. Now it has become longer and smaller in width, and this configuration it is maintaining even after we have withdrawn the deforming force. Now, what is a partly elastic body? The body is said to be partly elastic when after the withdrawal of the deforming force, deforming force, the body regains its original configuration. Partly, partly it will regain its original configuration. Right? The body will regain its original configuration partly, not fully. For example, let me draw. Suppose this was the body and you have applied force like this and like this, trying to stretch it. And after the application of this force, the body becomes like this. After the application of the force, the body becomes like this. And when you remove these forces, the body gains a little bit of its original configuration. For example, the body will become like this. Body will become like this. But it will never attain its original configuration. Which was this red one, right? right? So the actual board, the final configuration of the body will be in between its original configuration and its configuration when the deforming force was present.